Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 6 from the October-November 2023 Cambridge paper 4-3 mechanics. The mechanics paper, which is from syllabus 9709. And this question here is about variable acceleration. We're told that a particle moves in a straight line at time t seconds. The acceleration a meters per second squared of the particle is given by a equals 36 minus 6t. The velocity of the particle is 27 meters per second when t equals 2. So part A says find the values of t when the particle is at instantaneous rest. Now instantaneous rest means when the velocity is equal to 0. This is when the velocity is equal to 0. Okay, so what we have is the acceleration. We have the acceleration is given by 36 minus 6t. Now what we should understand is that we have displacement, we have velocity, we have acceleration. All right, so we have, if we want to go this way, okay, we have to, if we want to go from displacement to velocity to acceleration, we have to differentiate. Okay, but if we want to go that way, we have to integrate. All right, we can't use Suvat equations here because it's not constant acceleration. Acceleration changes as time goes on, as we can see. So we want to find the velocity, an expression for the velocity, we have to integrate this expression. So the velocity is going to be given by the integral of 36 minus 6t with respect to t. Now what we could do, instead of having to integrate and write plus c and find what c is, okay, is we could use some limits here. So I can say that I want to find what the expression for v, okay, when in terms of t. I know that when t equals 2, the velocity is equal to 27. All right, so I can integrate this within these limits, and I can use these limits for this side, and then I can find my expression for velocity, and then I can, find when the velocity is 0. So that's a nice, neat way of doing it. You could integrate, have plus c, find what c is by substituting the values in, but this kind of does that substitution in automatically from the start. So I'm trying to find an expression for v in terms of t. I know that when v is 27, t is 2, and that will help me to find the expression directly. So I'll leave this. This is going to be v minus 27 equals, let's integrate this first. So don't forget to integrate it, of course. So the constant term will gain a t because we're integrating with respect to t. So it'll be 36t, and you're going to add 1 to the power, so 6t squared over 2. Limits of t and 2. Okay, so now we have v minus 27 equals, we've got 36t minus 3t squared with the limits of 6 and 2. So when we put those limits in, we're going to find an expression. This is t and 2, okay, for what we need. So of course with t put in there, you'll get exactly 36t minus 3t squared. But then you've got to put 2 instead of t, so you have 36 times 2 minus 3 times 2 squared. All right, and that will give us what we need. So v minus 27 is 36t minus 3t squared minus, this is going to give me 72 minus 12. Right, that's going to be 3 times 4. So you have v is going to be 36t, minus 3t squared, and that's going to be 72 minus 12, which is 60, and that's going to be minus 60 plus 27. Add 27 to both sides. Now 60 plus 27 is going to give me negative 33. So v is going to be 36t minus 3t squared, take away 33, and that is your expression for your velocity. Now what we have to do is we've got to find when the velocity is 0. Okay, so when the velocity is equal to 0, we've got to find the values of t. So 36t minus 3t squared minus 33 equals 0. Now what we can do is we can divide by -3, in which case we'll end up with t squared, and that will be minus 12t, and that will be plus 11 equals 0. Okay, so we can factorize this. Looks like it's going to be -1 and minus 11. Those two will multiply to give you plus 11 and add to give you minus 12. So you end up with t equals 1 second and t equals 11 seconds. Those are the two times when it's going to reach instantaneous rest. Okay, we could have done it the traditional normal way by just integrating this. You'll end up with, v equals 36t minus 3t squared plus c, and then you can find what c is by replacing the v with 27 and replacing the t with 2. 72 minus 3 times, which is 12 plus c. So you, of course, you'd get the same answer, which is negative 33, and you would end up with this same thing here. Okay, both of them are perfectly good ways of doing it. Okay, probably in this case this might even look a bit easier, but I like to use this method. I have to write c at any point. I can just automatically gives you the value of c at the end. So there's the answer to question number 6, part A. All right, those are the values of t when the particle is at instantaneous rest. Now for part B, it says find the distance the particle travels during the first 12 seconds. Now many people, they mess up with this question because yes, we do understand we have displacement, velocity, acceleration, and if we're going this way, we differentiate. If we go this way, we integrate. And again, we have to integrate. We know that the velocity is equal to 36t. I keep writing this wrong. 36t minus 3t squared, and it was minus 33, was it? Minus 33. That's the expression for the velocity. All right, so we know that. And if you want to find the displacement, we have to integrate this. However, we know that the velocity is 0, okay, when t equals 1 and t equals 11. All right, so if we think about this, this is actually, if we rewrite this as minus 3t squared plus 36t minus 33. If we were to draw a graph, because we know the total distance is not the same as the displacement. Now, when you integrate this, you don't find the distance traveled, you find the displacement. So it doesn't take into account, basically the amount of ground covered. It just takes into account how far out of position the object is. So if this was going in one direction and then it changed direction, okay, the distance would be this value plus this value. That would be the distance. But the displacement would only be the distance away from the original point where it started, not the total ground it's covered. So if I just went and integrated this, if I integrate this, minus 3t squared plus 3t minus 33, okay, and I integrate this with respect to t between the limits of, for the first 12 seconds between 0 and 12, then it will, if there's a change in direction, it will basically it won't give us the distance traveled, it will just give us the displacement. And we can see that when if we were to draw a graph of this diagram, let me just draw a little sketch of this diagram. We can see we have a quadratic which is frowny face, which is upside down. Okay, so we have a quadratic which is going to be something like this if we were to make a little sketch of it. All right, and we can see that at 0 seconds, it's going to be down at negative 33 when time is 0. And it's going to go like this. It's going to have a parabola shape. It's going to go like that. So we can see here, that's 1 second, and there's 11 seconds. And we got to find the distance traveled in the first 12 seconds. So we can see for sure the velocity has become negative for some of that time. This region here and this region here. Okay, up to 12 seconds. Okay, so we can see for sure that there is these two areas here, which are in fact going to be exactly equal to each other because it's kind of symmetrical. It's 1 second away from the place where it crosses the axis, both of them. So those two areas are going to be negative areas, and this area is going to be a positive area. So this is positive, and these are going to be two negative areas. So if I just did this, it's going to subtract these areas from that area, and it won't give us the total distance. It will give us the displacement. So I can't do this. What I have to do is split it up into three sections. I have to integrate between the limits of 0 and 1, and between 1 and 11, and between 11 and 12. And then I have to add those areas together. Anything that comes out as negative, I'll write it as positive, right? So that's very important for us to realize. So first of all, we can take this expression and we can find what the integral of it is. Okay, so the displacement was going to be minus 3t cubed over 3. Let me just write it out properly. Yeah, that's supposed to say 36t, by the way. Plus 36t squared over 2 minus 33t plus c. So the displacement will be given by negative t cubed plus 18t squared minus 33t plus c. So now, if we're going to put limits now, okay, if we're going to find the distance now, that's for the displacement. The distance is going to be given by the limits between 0 and 1 for this, and then I don't have to write the c in there. So minus t cubed plus 18t squared minus 33t. I'm going to have the limits of 0 and 1. And then I'm going to have plus. Now, what I'm going to do with these limits, because I know this is going to give me a negative area, what I can do is I can switch them round and put here 0 and 1. If I switch them round, it's going to give me a positive area, right? That's all it's going to do. Okay, so that's a nice, neat way of dealing with that. Plus, and then I have to do the same thing, minus t cubed plus 18t squared minus 33t between the limits of 1 and 11. This is positive, so I'll leave it in that same form. Now, I know from the symmetry of this shape that this area and this area are the same. You can see from this, it's symmetrical. That's just 1 unit away from where it hits the axis. That's 1 unit away from where it hits the x-axis. So I can in fact take this and I can multiply it by 2, this first part here. And that will give me the same as that area there. Okay, that will be exactly this. And if I put here 11 up here and 12 down here, it will give me the same value. So take that, multiply by 2, add it to that, and that should give me the distance traveled, which will be this area plus this area plus that area. Okay, so now I need to do that. So I need to put those values in. So I'm going to say the distance, the total distance traveled, therefore is going to be 2 times. Now let me put these values in. I'm going to have 0 first, so that will all become 0. Minus, be careful of the signs here. That's going to be minus 1. That's going to be, if I put 1 in here, it's going to become plus 18. And minus 33. Okay, so that's that part. So we're going to put now 11 inside here and 1 inside here. So we're going to have here minus 11 cubed plus 18 times 11 squared minus 33 times 11 minus, and then we're going to put 1 in here as well, which will be the same as this, which if we work this out now, that's minus 34 plus 18, which is minus 16. Okay, I've just worked what that out is. So D is equal to 2 times, that's minus 16, which is 16, and plus, I have to add, I don't know why I put plus. Okay, that should be a plus here, not a minus. Plus, I'm going to have whatever this gives me here. So let's see what that gives me. That gives me negative 11 cubed plus 18 times 11 squared minus 33 times 11. Okay, and we're going to have plus 16, because because minus and minus is plus. So that gives us 500. So we end up with 2 times 1632 plus 500, which is 532 meters. That is the total distance that this object has traveled in its journey. Okay, if we had not done this, we would have got something which would have been 32 less than what we need. We would have had subtracted this 32 instead of adding it, and then we would have not got the correct answer. So there's the answer to this question, part B. Very important for us to realize how we deal with such a question, especially when the part of the velocity becomes negative at a certain point and we're finding the displacement. Very, very important. So that concludes this question. Other questions from this paper can be found in the playlist that will appear in this section over here. You can click on the link there. Other questions from the variable acceleration can be found in the playlist that will appear in this section over here. You can subscribe to my channel by clicking on this link, and this video that is linked over here will show you how to use my channel to find what you're looking for. Thank you for watching, and see you soon.